Hello everyone. All right, so we are going to start our chapter on stress today. And I simply cannot stress it enough. Pun is very much intended here. I simply cannot stress it enough how important this chapter on stress is to your entire study of mechanical engineering. And let me be very frank here. Every time I teach this chapter, whether it is in the context of mechanics, fluid mechanics, or mechanics of solids, uh, I simply cannot help feeling a certain sense of excitement as I begin to start this chapter. Uh, Now, it's rather unfortunate that I have to deliver this lecture in this kind of recorded fashion, because what happens in a real face-to-face class is that when I begin this chapter, I usually ask my students this question. Uh, then let's pause for a moment and try to think uh, uh, for some time about some possible application within the broad context of engineering, and perhaps even going beyond engineering in general physics, in general life, where uh, uh, where you try to think of an application where stress, as you understand from your previous studies of mechanics and fluid mechanics, the stress is not important. Okay, I'm not asking you to think of an application where stress is important. Rather, I want you to think and try to find out an application where stress is not important. So, since we are not meeting face to face, the best thing that I can request you is to pause this video for half a minute, maybe. Just pause this video for half a minute and think. Okay, so I'll wait. So you pause this video now. Go for it. So if you have really paused this video, thank you, and I hope you have some answers. But to those who didn't pause, well, let's go ahead. Um, so I've tried to think of this answer, and every time I try to think, no matter which application area I think about, I simply cannot find an example where there is absolutely no relevance of stress. You can think of huge man-made structures like ships, uh, aircrafts, spacecrafts, uh, uh, vehicles, the robust machinery present inside vehicles, the robust machinery that is present in industrial settings. Starting from those robust machinery, come down to very small applications, very household applications, like things for domestic use, like tables, chairs, almirahs. Come down to even smaller things, even more delicate things like watches, and not just mechanical watches, mind you. Even your mobile phone. Okay, the ubiquitous mobile phone, this very laptop that I'm using, this pen tablet that I have beside me, anything that you may think about, and certainly your bicycles, uh, which are just, well, sadly lying in your hostel sheds. Um, in every aspect, you will find the application of stress. So as far as mechanical engineering and mechanics is concerned, this right here is the heart and soul of mechanical engineering, I believe. Okay, there are a number of other important things in mechanical engineering overall, but as far as the absolute core fundamental concepts is concerned, stress is right there at the top. Okay, so this is like the heart and soul of mechanical engineering. All right. So with this little pontification, so to speak, we will start our chapter of stress. Now, when we do that, because it is such an important thing, as I've just emphasized, what we'll do is we will try to start at the very basics. Okay. Now, when I say basics, it doesn't mean very necessarily very simple things. Uh, uh, but very fundamental things. Now, when we do that, perhaps some of you will detect a lot of similarity with what you have already studied in mechanics and fluid mechanics, and that will be true. Of course, you have studied some of those aspects, but there will be some crucial differences. And especially when contrasted with what you studied and the way you studied stress, analysis of stress in your first year, and how you will study and approach this concept right here in mechanics of solids in your third year level. One of the most fundamental differences will be in the concept of traction across a plane at a point. So this new word traction, this is where we'll start our entire discussion. Now we will get down to the mathematical representation of it and down to the nuts and bolts of it. But again, I want you to think, and this is a discussion which I remember having with each of your previous or each of your senior batches in the past 2-3 years. That the moment I mention traction, what kind of imagery does it bring to your mind? So I've asked this to seniors, and in a live face-to-face class, of course, and it was a very lively discussion, and almost always the some of the students, they point out that this word traction, they come across very commonly, especially in the commentary of Formula One racing. So suppose there is a little bit of rain going on, and the Formula One cars are riding at very high speeds on those tracks. So perhaps the commentator will say something like or perhaps comment on something about how much traction the tires are getting on those slippery tracks because of the rain. Now there's a lot of interesting things regarding the traction of Formula One tires. There are different varieties of tires, and I'm sure those of you who are in team kart will find this particular aspect of discussion fascinating. But in the interest of time, let us not get into that. If you want, maybe we can have a separate discussion on it in our discussion boards or something like that. But maybe not in this recorded lecture. So coming back to the beginning of a chapter, this is where we'll start. Traction across a plane at a point. Okay, so we'll actually begin with the real discussion as far as our syllabus demands it in the next part of the lecture. And again, I hope that you will share the excitement of this entire chapter with me all throughout. Thank you very much.